Okay, so members, now we are going to see how do we use algorithm or the geometric frequency curve to generate the median, the percentiles, and then the deciles. But please don't forget to subscribe to the channel. Okay, to start with, this is an example we have here. We are going to see, I've done the example, I'm just going to go through the explanations. The table below shows the ages of students. These are the ages. So those with the 5 to 9, they are 2, 10 to 4, they are 8, 15 to 19, are those up to 5. They are here. Construct a frequency table and use it to calculate the mean age. Draw a geometric frequency curve and use it to find the median, lower quartile, 90th decile, and the 60th percentile. Now, of course, we need to consult now the frequency distribution table. We put here these classes in terms of ages, of course, now. Then this number of students, now they are going to turn to be now the frequency. This one is 2, is there. Now, always the number of those students in that class, it's the frequency corresponding to that class. So 14 are 8, as you see. Then you see 15 to 19, they are 12, as you see here, and so on. Because now we are going to construct the frequency curve, we also have geometric curve, we need also the geometric frequency. So now, to get the midpoint, I told you get this plus this divided by 2. Then this plus this divided by 2, this plus this divided by 2, get this, and so on up to reach here. But the easiest way is, you get the class boundary, or the class width, or the class size. By getting this minus this, then plus 1. Then after getting the first, just add on 5, 5, 5, 5. Instead of here, when you 7, you add the 5, you get 12. You add the 5 here, you get 17. You add the 5 here, you get 27. You add the 5 here, you get another 2. That is the easiest way. Then, we also, because the geometric frequency curve is called against, with geometric frequency, with the ages, all the class limits, we need here the class limits. So you need to go under the adjustment factor. How do we get? You get this minus this, or this minus this divided by 2, this minus this divided by 2, can use any, as long as you are getting this minus this. So now I use the 15 minus this, then divided by 2, 0.5. So you subtract here 0.5 and add here 0.5. That's what we've been doing. Here 0.5, you add here. You subtract here 0.5, then you add here 0.5. Subtract here 0.5, you get this. When you add here 0.5, you get this. But always, I told you, these ones are going to be the same. So when you get this, it's going to be always the first lower class limit in the next class. This one is going to be the first class limit in the lower class, in the upper class, and so on like that. So that's it. How we get the adjustment factor. The adjustment factor. Then when we come, now the question wanted us to first of all get the mean. Now the mean, we know that it's given by summation f of x over summation f. So from there, instead of our summation f, we just add our frequency. So if we add this, and this, you get 30. This one means we are summing frequency. Then to get f of x, now we need what we call the midpoints. How do we get the midpoints? You get this plus this divided by 2. So then to get fx, you multiply f and x. So get this times this times this times this times this, up to reach this times this, you get that. Then you sum this one because you know they are sum. So sum of f of x is 515. So to get mean, you get summation f of x over summation f. When I put there my summation f of x, here, then summation f is 30. When I divide, that's what I get. So now in part B, the one that's to get to use the geometric frequency curve to find. Now, how do we put the geometric frequency curve? Or is to put the geometric frequency curve, we put using the classes, the upper classes here, with geometric frequency. Now, so that my geometric frequency is from 2, 10, 22, 26, 29 up to 30. I think remember I will get the geometric frequency. The first frequency is the first geometry. You get this, plus this, you get 10. Then this, plus this, you get this. This plus this, you get this. Then this plus this, you get this. This plus this, you get this. That's how you get the arithmetic. Now using this scale, which is at the scale of 2 centimeters, for 5 is going to be the perfect scale here. So that's why I'm having from 0, 5, 10, 15, 20, 25, and then 30. Then we are putting geometric frequency curve, as you say, geometric frequency here. Then we are putting here what edges, heights, and so on. But this question is giving us edges. That's what I'm putting here. Then we start. This first class is orange. It's better orange to put it here as the first. Then this one comes the second. This one now, 9.5 goes with the geometry is 2. That's why 9.5 is going with the 2 here. Then 14.5 is going with the 10. That's why 14 is going with the 10. Then 19.5 is going with the 22. 19 is here. Then 22 is here. Then when we come to 29.5 goes with the 29. 29.5, 29, I think that 29 is somewhere there, 29. Then 34.5 goes with the 30, geometric frequency 30. That's why it's that 34.5 is here, the 30 is there, that's where they meet. Now, the way they are stars, that's how they've been put. Now, you join those points using a free hand. So join from here, like this, a free hand. Then you continue like this until when you reach there. Though that orange, this curve is going to make something like an S shape. I think you see that orange. So that's how we call the geometric frequency members. So how do we use now to find the deciles, the percentiles, and then the median? So after plotting it, that's how we plot it. Then I'm going to get now these ones. Now, orange in our formula, remember, when we are calculating the median, the n or the summation f is divided by 2. So we first come to this orange. So if we compute this, our summation f is 20 divided by 2 is 15th position value. Now this one, you trace this one in the geometric frequency. So where 15 is here. Now you draw from 15 this until when you reach the curve. So you connect until when you reach the curve. Then when you reach the curve, you go down. You want rid of this. So here, remember we want rid of the yards. That's why you go down. So you reach here. So now 10 small squares here is the 10 small squares. But between every 10 small squares, there are 5 yards. I want to know what each small square is. Divide by 10, divide by 10. Divide by 10 is that one small square is having 0.5 yards. Because don't really calculate these ones. So now for median, we start for median is here. Now we start, first of all I have 14. Then plus, these small squares here are 4. 4 small squares times what is small square represents 0.5. When you cut it there, you get 2. Then this plus this, that's why I'm having 16 yards. When I come to lower quartile, no lower quartile will multiply summation f with a quarter. Remember to do the quarter, that's what you get. Now you come on the geometric frequency and look for 7.5. 7.5 is here. Then you draw a line when you reach this curve. Then when you reach this curve, now you bend downwards. Rid of this value. Good enough to know that it's already 9.5. So already 9.5 times. From here up to here, there are 7 small squares. So these are 7 small squares, but each small square is having 0.5. That's why I'm multiplying by 0.5. And I get that there. Then when I add, I get 13 yards. Then when I come to this side, we say multiply with the 9 over 10. If it's 8, you say 8 over 10. If it's 5, you say 5 over 10, like that. And it's the summation f. When you multiply this one, you get 27. Now you come on geometric frequency and look where 27 is. 27 is here. So when you draw a line from here, then like that, then you come here. Then, from here, start there are only 3 small squares that are passing. So, I get this then plus the 3 small squares times 3. Be giving me 1.5, when you add here, you get 6. When you come down to the 60th decimal, you get 60 over 100, I mean percentile. Percentile means over 100. To get 6 over 100 and the summation f, this is what you get, 18. Now come here and look for your 18. 18 is here. Then you draw a line. When reach here, using a ruler, then you go down. Start here, we are having 8 small squares. So we add 14 plus this 8 small squares, and what each is representing. So 8 and 0.5, because each is 0.5. And that's what we get. We get 18.5. The other how to trace or what that is, you check from here to here, meaning that every one small square here is representing, from here up here there are 5, but from here up here there are 10 small square, meaning every small one is having 0.5 also. So you just get the value you want. You want to get this value 18. So get those small 18 divided by 10, I mean the value of a small square. We know how many small squares you want to count from here and so on. So that's it, members. I wish you the best.